Okay. If you have this equation, you can solve it, okay? Because this means that either this thing is 0 or this thing is 0. So just break it into two equations, okay? So you have this, okay? Yeah, set this equal to 0, that would make the whole thing 0, right? Set this equal to 0, that would make the whole thing 0, okay? So you solve. I think maybe you get something like x equals 5.4, 5 and 20/36. Well, actually, I can do that. That's 5/8, so it's actually a little low. 5.625. Just look out on that. Give me a well-known fraction. Okay? Over here, that's not going to happen. That's not going to give you anything you can do much with. So, what's your solution? It's x equals negative 0.8. Sorry, negative 4.2 plus or minus the square root of 4.2 squared, okay? Which is 17.64, something like that. That might be right, but I'll just go 17.6. We're going to get an approximation anyway. Minus 4 times this, okay? Now 4 of these is 3.2. 3.2 times 1.8 is pretty close to 6. So I'm just going to leave it that way. Just get an approximation. Over 2 times 0.8. Okay? Now that adds up to about 23, which is a little less than 25. So this number is going to be a little less than 5. And I'm not going to go through all the details because you both know how to solve quadratics. You're pretty good at it. But if I added 5, I'd get like 0.8, it's going to be like 0.7 over this. So I'm going to say it's maybe 0.4 or negative 9 over 1.6. Now that's very approximate, but I wanted to get approximations. I could have just left it here or just done the substitution and left it because everybody here knows how to solve it. Okay? But let's just look at what happens now if you try to graph this function. Okay? So let's say your problem was you start with f of x equals 0.36x minus 2 multiplied by 0.8 x squared plus 4.2x minus 1.8. So here are your zeros. Your zeros are at negative 6, 5.625, so we'll just say 5.6, even though we can do that one exactly, assuming I did it right, and 0.4. And then you have a y-axis with the y-intercept. And the y-intercept, well, everything's got an x on it, it's going to give you 0, so you're going to have negative 2 times negative 1.8. So that would be 0, 3.6. Okay. Big negative x. X way to this side of negative 6 is going to make this negative, because that's going to be negative and you're subtracting from it, right? And this is going to be guess you gotta go quite a ways from negative, no, it isn't, yeah. Yeah, you gotta go a little ways from negative 6. Okay, but well, if x is negative 6, you're gonna get 36 here from the x squared, right? 8/10 of that's not gonna be all that much less than 36. Of course, that's gonna be a little over negative 24, okay? So that's gonna be pretty close to 0, but of course that's a 0 of the function, so that works out. But if x goes to negative 10, then you got x squared is 100. So that's going to be like 80. This is only going to be a little over 40, and that's not going to help you any. So this is going to be positive, right? So you got two factors. To the left of negative 6, you've got a negative and a positive, which makes it negative, meaning you've got to do this. To the right of 5.6, everything is going to be positive. If 5.6 really is the root, but just go out a little more than 5.6, go out to 10, see what happens. It's going to be clear that everything is positive, so you're going to have a positive times a positive is a positive, it's going to go way up. Between negative 6 and 0.4, it can't change sign because it can only change sign by going through a 0 or cross an asymptote. We don't have any denominators, there aren't going to be any asymptotes. So it's going to be positive in here. And then from 0.4 to 5.6, you pick a number between 0.4 and 5.6, pick 2. Okay? If you got 2, you got about negative 1.3. So that's negative, and clearly if you plug in 2, that's going to be positive, because this is going to be positive, this is going to be positive. It's going to be a lot bigger than 1.8, so it's going to remain positive. So now we know it goes from negative through this, positive from here to here, and then goes negative, and then it goes positive again. Okay? Now when it does that, it's got to get all the way from here to here. It's going to be really steep here. People have a tendency to want to make the y-intercept the maximum. That's clearly not going to happen. There's no smooth way to get from here all the way over to here, and then just, you've almost got to make a right angle to get down here. You can tell by that this thing is going to go way up here, and then it's going to come way down here. Probably going to go way down here before it goes through here. Okay? So we can graph this expression. And those are some of the techniques. It's kind of worth reviewing some of those techniques.